Good afternoon and good evening. This is the second day of Chapter 5, Section 4. We are now going to work with multiplying and dividing uh, complex numbers. Just like I gave you notes yesterday, over the weekend on this, you're going to see more examples of this so you can do the homework tonight. Today, all we did in class was addition, subtraction, and solving using imaginary numbers. Today we're actually going to multiply and divide using imaginary numbers. So just like in the homework yesterday, we want to write this expression as a complex number. A complex number in standard form is ax plus bi, where a is a real number, b is a real number. A is the real part, bi is the imaginary part. So what I want to do here is I want to distribute the negative I into these parentheses. So I get negative 3i minus I squared. Well, I need to remember that I squared is negative 1. So this is minus a negative 1. So this is negative 3i plus 1. Excuse the board. So in the standard form, it's going to be 1 minus 3i. That is my answer. I put my real number, my real part is 1. My imaginary part is negative 3i. That's how I do one of these problems. Let's look at part B. In part B, I have to FOIL, or I could use the box method. If I go ahead and use the box method, I put 2 plus 3i along the top, negative 6 minus 2i along the side. Draw my boxes. 2 times negative 6 is negative 12. 3i times negative 6 is negative 18i. 3i times negative 2i is negative 6i squared. That was a mistake. Give me a second. 2 times negative 2i is negative 4i. 3i times negative 2i is negative 6i squared. I know that I squared is negative 1, so this is negative 6 times a negative 1, which is 6. Combine like terms. My real parts, negative 12 and 6 gives me negative 6. Negative 18i minus 4i is negative 22i. There is my final answer. So let's go on to my next problem. Remember, recognize, and notice that these are complex conjugates. That means it's the same problem, but one's addition and one's subtraction. Whenever I multiply complex conjugates, I will always just get a real number. I will never get an imaginary part. The imaginary parts should multiply out. So if I use the box method, this is 1 plus 2i. This is 1 minus 2i. I draw my box. 1 times 1 is 1. 1 times 2i is 2i. 1 times negative 2i is negative 2i. 2i times negative 2i is negative 4i squared. I squared is negative 1, so this is negative 4 times negative 1. Negative 4 times a negative 1 is 4. Combine like terms. 2i minus 2i cancels. 1 plus 4 is 5. So my answer is a real number, the number 5. That's multiplying complex numbers. Hopefully that makes sense to you. The next two pages are dividing complex numbers. Let's look at this. Write the quotient. 5 plus 8i divided by 1 minus 2i is a complex number in standard form. A plus bi. Remember that I squared equals negative 1. I want to start with my problem. 5 plus 8i divided by 1 minus 2i. Remember how this works. I do not want a complex number or any part of an imaginary number in my denominator. So that tells me I have to multiply by something to get rid of my denominator. And when I multiply, I need to make these factors. So I'm going to multiply by the complex conjugate of my denominator. 1 minus 2i, the complex conjugate, is 1 plus 2i. When I do the one part, I have to do the other. So this is 1 plus 2i in my numerator as well as my denominator. It means I'm multiplying by 1, so the problem doesn't change. Let's go ahead and do the box method. In the top, this is 5 plus, this is 5 plus 8i. In the times 1 plus 2i. Draw my box. 5 times 1 is 5. 8i times 1 is 8i. 5 times 2i is 10i. 8i times 2i is 16i. Combine, 16i squared. I squared is negative 1, so this is 16 times negative 1, which is negative 16. That's better. Combine like terms. 5 minus 16 is negative 21. 8i plus, let's try that again. 5 minus 16 is negative 11. 8i plus 10i is positive 18i. And there is my answer. That is my numerator. Negative 11 plus 18i. What's in my denominator? Well, let's find out. Again, using the box method. On the top, I'm going to put 1 minus 2i. And along the left, it's 1 plus 2i. Draw my box. 1 times 1 is 1. 1 times negative 2i is negative 2i. 1 times 2i is 2i. Negative 2i times positive 2i is negative 4i squared. That's negative 4 times a negative 1, which is 5. My 2i and negative 2i cancel. 1 plus, negative 1 times negative 4 is positive 4. I'm moving too fast. 1 plus 4 is 5. So my answer to my denominator is a real number, 5. I do not have an imaginary part. So that tells me I can break this up into a real part, negative 11 fifths, plus an imaginary part, 18 fifths I. There's my real part, there's my imaginary part, there is my standard form, and there is my final answer. Hopefully that's making sense to you. Let's go ahead and try one more division example so you can see it one last time. Write the quotient 4 plus 3i divided by 2 minus 5i as a complex number in standard form, a plus bi. A is the real part, bi is the imaginary part. Remember that I squared is negative 1. So same thing, 4 plus 3i divided by 2 minus 5i. I cannot have 2 minus 5i, an imaginary number in my denominator. I have to multiply by my complex conjugate, 2 plus 5i, to both the numerator and the denominator. So I'm going to go ahead and multiply this out. My numerator, again using the box method, 4 plus 3i, 2 plus 5i. 4 times 2 is 8. 3i times 2 is 6i. 4 times 5i is 20i. 3i times 5i is 15i squared. I squared is negative 1, so this is negative 15. Combining like terms, 8 minus 15 is negative 7. 6i plus 20i is a positive 26i. So my numerator is negative 7 plus 26i. I now need to find my denominator. Since I'm using my complex conjugate, I should and we'll come up with a positive real, no, excuse me, come up with a real number. Doesn't have to be positive. So I put 3, that's not correct. So I put 2 minus 5i in the top, 2 plus 5i along the left. I draw my box. 2 times 2 is 4. 2 times negative 5i is negative 10i. 2 times 5i is positive 10i. Negative 5i times positive 5i is negative 25i squared. I squared is negative 1, so that's negative 25 times a negative 1, which is positive 25. Combining like terms, 10i and negative 10i cancel. 25 plus 4 is 29. So my answer for my denominator is 29. I can now break this up into a real part and an imaginary part. Negative 7/29 plus 26 over 29i. Again, I have to make sure I end up with an imaginary part and a real part as my answer in standard form. I need to make sure that there is no imaginary part in my denominator, and I'm done. That's multiplying and dividing real numbers, complex numbers. See you in class tomorrow.